In previous video we had discussed about the scalar product, that is the product of two vectors gives a scalar quantity like the work which is the product of the force and the displacement. Force and displacement both were vectors, but the resultant work is a scalar quantity. Now in this video we'll discuss about the vector product, that is the resultant is a vector quantity. So how can we define? First of all, we'll see its definition. Suppose two vectors are vector A and vector B are there. Okay, so its cross product is always equal to the product of their magnitudes, because A and B are A is the magnitude of vector A and B is the magnitude of vector B. So product of their magnitudes and the sine angle between them. Okay, because it is a vector quantity, so we'll write n cap also. N cap, you know, it is a unit vector. Okay, so n cap, it is the unit vector. Already you know about it. So this is the definition of the vector product. So I repeat, the vector product of two vectors is always equal to the product of their magnitudes and the sine angle between them, and the resultant is always perpendicular to given vectors. It means, dear students, suppose one vector is in the direction of x-axis, suppose the second vector is in the direction of y-axis, then the resultant will be always in the third direction. Okay, third direction. Okay, that is the along the z direction. So resultant is always perpendicular to the given vectors. Now see the examples. Okay, to understand the example, I'm taking a few short examples. Like the first example, you can see, as studied previously, the torque, you know, it is equal to the position vector r and the force. Okay, position vector, it is a perpendicular distance and this is the magnitude of force. So torque is a vector quantity because it is the resultant of two vectors. Okay, another example you can take, that is the angular momentum is the product of position vector r and the linear momentum. So that's why it is known as we say that is the moment of the linear momentum is always equal to the angular momentum. Okay, here the linear momentum is multiplied by the distance, so it gives position vector r is the position vector, this is the angular momentum, it is again vector quantity. Okay, we can see one more example, very common example, that is the v is equal to omega into r. Okay, so velocity is equal to, linear velocity is equal to angular velocity and the product of the angular velocity and the position vector r. Okay, so v is equal to omega r. This is another example. So students, after this we have to discuss the properties of the vector product. Okay, now coming to the properties. Okay, so one by one we'll take all the properties. Like the first property, you know, in the same way of the scalar product, the cross product of two vector is not commutative. Okay, it is not commutative. In the dot product, you know, it was a dot b is equal to b dot a, but in scalar, in the vector product, it is not equal, so it is not commutative. This is the difference also. You have to remember, this is not the commutative. Okay, and second property we can see, it is the distributive, like the scalar, so it is the distributive. Okay, scalar was also distributive. Distributive means the vector a cross b plus c it is equal to the A cross B plus A cross C. But dear students, you have to remember about the sequence. It should not be changed. It should not be changed, because according to first, A cross B not equal to the B cross A, but it is equal to the with negative sign. Okay, A cross B is always equal to the minus B cross A. So this is the property. So if you reverse or change the sequence, then the resultant will change. Okay, because A cross B is equal to the minus B cross A. So don't change sequence. This is the second property. Now come to the third property. Suppose two vectors are perpendicular to each other. Okay, perpendicular. In that case, A cross B is equal to AB. According to definition, here theta is equal to 90. So AB sine 90 n cap. So sine 90 is equal to 1. So it is the equal to the AB. Okay, so if the given vectors are perpendicular to each other, then the resultant is always product of their magnitudes in perpendicular to given directions. Okay, perpendicular to both. Okay, AB. This is the another. Now come to the fourth property of the vector product. Suppose both given vectors are parallel. Okay, parallel means theta is equal to 0 degree. Okay, so in that case, what will happen here? The sine 0 means 0. So we can write AB sine 0 n cap. So it will be the 0. So we can write 0 like this, 0 vector like this. Okay, or simply we can write the 0. So the product of two vectors, if they are parallel to each other, is always 0. Okay, its magnitude will be always 0. Now students, come to the another of important property about the orthogonal unit vectors. Orthogonal unit vectors, you know, I, J, K. Okay, so I cap, J cap and K cap. K cap have the following relation. You have to remember following relations. Okay, suppose we'll discuss two types, that is the perpendicular and the parallel. Okay, so vector I, vector J, you know, it is equal to the minus J cross I, because it is not the commutative. Okay, it is not the commutative. Okay, and it is in the third dimension, that is the K cap. Its magnitude is 1, and the resultant is perpendicular to this. So I is the along x-axis, J is the along y-axis, so resultant will be along the z-axis. Okay, so suppose this is I, this is J, so it is the K cap. Okay, K cap means a unit vector along the z-axis. Okay, and its magnitude is 1. So you can write like this also, Jk is equal to minus Kj, and it is along the x-axis, I cap, or K cross I, it is equal to minus I cross K, and it is equal to the J cap. Okay, this is the first case. Now the second, if the vectors are parallel. Okay, suppose I cap and the I cap. So what is the angle between them? Because both are the vectors in the same direction, so angle is 0. So here in the same case, angle is 0. So that is the AB sine 0 n cap. So it is equal to 0. Okay, magnitude of this sine, and the angle is 0. So we can write here 0. So 0 n cap. n cap, or simply we can write the 0. Okay, so it is similar I, j, k like this. That is the I cross I is equal to 0. It is j cross j or k cross k. All are 0 here. Okay, all are here 0. So this is the relation. This is the relation for the orthogonal unit vectors I, j, k. Now students will discuss its last property, that is the product of two vectors. Okay, the vector, the last property, seventh property, the vector product of two vectors, the vector product of two vectors in terms of their x, y and z component. Okay, as a determinant we can discuss. Suppose the two vectors, vector A, it is given, it's three-dimensionally ax I cap. Ax is the magnitude along the x-axis, I ay j cap plus az k cap. Okay, and the vector B is equal to bx I cap, by j cap, and the bz k cap. Okay, so if we have to find its product, vector product, then how can we find it? We'll find like this, A cross B. Okay, and easy method to solve it, that is the A cross B. What you have to listen, you have to write in this form I, j and k. First write like this. Okay, and then because I, j, k shows only the directions along x, along y, along z axis. So now here for A, write ax, here ay, and here az. Similarly bx, by and bz. So you can solve in the determination method. Now come to this question arises, how will solve like this one, how will solve? Okay, to solve it, remember I minus j and plus k. Okay, now how will fill this? To write this gap, just hide this row and this row. Okay, this row. So what can you see? It is the ay, az, by, bz. Is it clear? Now for j, hide the j and like this. Okay, now what you can see, it is the ax, az, bx, bz. Clear? Now for the k cap, hide the k and c and write the same which you can see here, ax, ay, bx, by, bx and by. Okay, in the first step to find the vector product, write in this way. Now in second step, what you will do, just see. So write here A, first write this one. Now multiply A, y, b, z, a, y, b, z. First multiply this one, and this, it is the AY, it is the BZ. Okay, I have written. Now with minus sign, write BY into AZ, minus with minus sign. Remember students, this is the method. So BY AZ, clear? Now for this minus J cap, apply the same thing, AX BZ, AX BZ, and minus BX AZ, minus BX AZ. Okay, and now for K cap, same way, AX BY, AX BY minus BX AY. Okay, so this is the product, vector product of two vectors in terms of their x, y, and z component. X component, y component, and z component. So dear students, these all, that is the 7 properties of the vector product. With the help of this, we can solve any questions, any numerical based on the vector analysis. Thank you students.